You know that feeling, right? You hit the power button on your computer, ready to get to work, and absolutely nothing happens. Just silence. It's one of the most frustrating moments for sure, but it's also a mystery just waiting for us to solve.
So, you're just staring at this lifeless box on your desk. What's the first move? Do you panic? Maybe start randomly unplugging things? Nope. This is where we stop guessing and start thinking. This is where our investigation really begins.
That's exactly right. We're going to put on our detective hats and approach this whole thing logically. By following a clear process, by looking for evidence, we can systematically figure out what's gone wrong. You'll see every single symptom is a clue, and honestly, every component is a potential suspect.
So here's our game plan. We're going to start with suspect number 1, the power supply. Then, we'll figure out how to decode the computer's secret language of beeps. After that, we'll solve the mystery of a missing operating system, and finally, we'll look at the classic signs of a failing drive. Let's get to it.
Okay, first things first. Nothing inside your PC works without a steady supply of power. So if you're getting absolutely nothing, no lights, no sounds, no signs of life, our prime suspect has to be the power supply unit, or PSU. We've got to check if anyone is even home.
The very first thing you do is just use your senses. Look and listen. When you press that power button, you should hear fans roaring to life almost instantly. If you see lights on the front panel or hear that spin up, that's a huge clue. It means power is getting somewhere. But if all you get is dead silence, well, that tells us the problem is probably way earlier in the power chain.
And this right here is a perfect example of that detective work, working backwards from the effect to find the cause. You always start simple. Is anything else in the room off? Maybe you just tripped a circuit breaker. No? Okay, plug a lamp into the same socket. Does it work? Good. Now, check the power cable itself. Is it plugged in tight, both at the wall and into the PC? You would be shocked how often that's the problem. From there, we slowly work our way inside, checking connections and ruling things out one by one.
Now this is really cool. The tool you see here is a power supply tester. It's pretty much the only way to know for sure if the PSU is delivering the right voltages. But look closely. Notice the professional setup? You have to take safety seriously here. And I mean it. Never, ever try to open up a power supply unit yourself. They hold a charge. If you've done all the other tests and you think the PSU is dead, the solution is simple. You replace it. You don't repair it.
All right, so let's change the scenario. Let's say the fans do spin up, you see some lights, but your screen is just black. Our investigation now moves to the next critical phase, the power on self-test, or post. This is when the computer literally tries to tell you what's wrong.
So, what is the post? Well, think of it as the system's own internal detective. Before it even thinks about loading Windows or macOS, the firmware does a super quick check on all the essential hardware, the processor, the memory, the video card. It's like a morning roll call for the most critical components in the system. Now, if the post finds a problem that's so serious it can't even show an error message on the screen, it has to use a backup plan. It uses that tiny little internal speaker on the motherboard to send out signals. But what on earth do these beeps actually mean?
This is basically the computer's secret code. These beep patterns are direct clues that point you right to the faulty component. For example, if you hear one long beep followed by 2 short beeps, your prime suspect is the video card. The computer is literally telling you, hey, I can't see anything. A continuous, non-stop beep, that almost always points to a problem with your memory, your RAM. Learning these codes is like learning to understand your computer's cry for help.
But what about the trickiest case of all? You get power, a blank screen, but no beeps. That's a tough one, because it might mean the post isn't even starting. So we have to ask ourselves, what could stop it? Well, a recent firmware update that went wrong could do it. Or maybe a graphics card, or a stick of RAM that isn't seated properly in its slot. It could even be a sneaky fault with the PSU, where it's sending some power for the fans, but not the special power good signal the processor needs to wake up.
Okay, let's imagine we're past all that. We got power, and we heard that one beautiful, short, satisfying beep. That's the all-clear signal. It means the hardware check is complete. So what's next? The system's job is now to find the operating system and hand over control.
And this is where you might run into an error like boot device not found. It's so frustrating, right? The computer is basically saying, hey, I'm ready to go, all my parts are working, but I can't find the instructions. I don't know what to do next. At this point, our investigation shifts from the core hardware to the storage drive where that operating system is supposed to live. Now, what's really interesting is how the system even knows where to look. It uses something called a partition map, and you can see there are two main types. MBR is the old school way. Think of it like a fragile old paper map. If that first little bit gets torn or corrupted, the whole map is useless. GPT, on the other hand, is the modern system. It's way more like having a GPS with built-in backups. But if the data on either of these maps gets messed up, the computer gets lost and just can't find the OS.
Okay, so let's say the system finds the OS and starts to load it. Things look good for a second, but then, boom, disaster strikes. And this is where our investigation leads us to the most infamous clue in the entire world of computing.
Ah yes, the blue screen of death. We've all seen it. This crash screen is basically Windows throwing its hands in the air and yelling, "Something is fundamentally wrong here, and I can't keep going without risking everything." And while bad software drivers can cause it, very often it's a symptom of failing hardware, especially a storage drive that's starting to corrupt those all-important system files.
A dying drive will often give you other warnings before it completely gives up. If you have an older mechanical hard drive, listen for any weird grinding or clicking sounds. That is the literal sound of a mechanical part failing. For any kind of drive, watch out for the little hard drive light on your case being constantly on, a frantic blinking called thrashing, or maybe you're getting errors when you try to save files. These are all huge red flags that you need to back up your data right now.
But what if we could see this coming? What if we could know a drive was in trouble before the clicking starts or the blue screens appear? Well, we can. This is where our investigation gets proactive, using a technology that's built into almost every modern drive.
And this shows you exactly how it works. It's called S.M.A.R.T, which stands for Self-Monitoring, Analysis, and Reporting Technology. Basically, your drive is constantly keeping a diary of its own performance, tracking things like error rates and how long it's been running. Special utilities, like the one you see here, can read that diary and give you a full health report. If key numbers are starting to look bad, the system can actually warn you that a failure is likely just around the corner.
So there we have it. We followed the clues from a machine that was completely dead all the way to a drive that's warning us about its own future. And throughout this whole process, notice that we haven't been guessing. We've been using pure logic.
And really, it all boils down to this simple mantra. Always start with the simplest, most obvious explanation, like a loose cable. Follow the boot up sequence step by step. Power, post, bootloader, operating system. And most importantly, listen for the clues the computer is giving you, whether it's the silence of no power, the sound of a beep code, or an error message on the screen.
This, right here, is the absolute heart of troubleshooting. You see an effect, like a black screen or a system crash, and you work your way backward, testing one possibility at a time until you find the root cause. It's a really powerful way of thinking, and honestly, it applies to way more than just computers.
You now have the mindset of a digital detective. The tools are there, and the logic is yours to use. So the next time a piece of technology lets you down, you won't just see a broken gadget. You'll see a case that's just waiting to be solved.